right, so let's say that I've used the art technique to take this edge here and sweep it down here, and I've made a gorgeous golden rectangle. So now there's this really cool fact about this golden rectangle that I want to prove to you guys using algebra. And it's that this golden rectangle is made up of a square, duh, we knew that, and another golden rectangle. And that's like mind-blowing, right? So what we need to do is we need to prove that this guy right here, this part of the shape, is literally a golden rectangle, which means that the ratio of the sides, long divided by short, has to be the golden ratio, phi. And so notice that the long side is actually equal to 1 now. And if this was phi, and if this was 1, that means that this little short guy has to be phi minus 1, right? So what I'm saying is long over short is equal to the golden ratio. This is the thing I have to prove. It's going to get algebraic, but if you're down with the fraction math, it turns out okay. This is what it looks like. So I need to write this down, and I'm actually going to write down what the phi is here. So we're going to have 1 over 1 plus radical 5 over 2 minus 1. Okay? That's the thing that I have to prove, that this expression is literally equal to that. And so what this is equal to, I'm going to combine these two pieces in the denominator using common denominators, right? So 1 is equal to 2 over 2. And so this is 1 plus radical 5 minus 2 all over 2. So when you turn this into 2 over 2, you'll be able to combine these into a single fraction. So notice how we have like a big fraction bar, and then all of this is sitting underneath at the bottom. So what is this equal to? So remember that when you're dividing fractions, and you can view this, think of this as 1 over 1, right? So we have fraction divided by other fraction, and what you do is you multiply by the reciprocal, right? You take this guy and you flip him upside down. So let me write down what that's equal to. You have 1 over 1, that's the top, times 2 over 1 plus radical 5 minus 2. Now I'm going to choose to write that as radical 5 minus 1. Okay, so it's starting to get a little bit better, right? It's not a compound fraction anymore. And also, you guys probably already know that if you multiply this by 1 over 1, you might as well not do anything. So I'm just going to cross it off. But this doesn't really look like that yet, right? So there's this technique that's taught in algebra. It's called rationalizing the denominator. And you use the conjugate for that. And I don't know if you remember what that means, but you take this, the conjugate of radical 5 minus 1 is radical 5 plus 1. And so what you're going to do is you're going to multiply this expression by radical 5 plus 1 divided by radical 5 plus 1. So by doing that, what's going to happen is when you FOIL on the bottom, when you distribute, you're going to not have square roots anymore, and that's awesome. In fact, what happens is when you FOIL, you have the first, outside, inside, and last, and the outside and the inside cancel each other out. And what you're left with here is 2 times radical 5 plus 1 all over 5, radical 5 squared is 5, minus 1 squared. So it's all over 4. Now it's looking really close, isn't it? The 2 and the 4, they're going to simplify. Instead of radical 5 plus 1, I'm going to write 1 plus radical 5 all over 2. And so I won. It turns out that 1 divided by phi minus 1 is literally exactly the same real number as phi. And so this little rectangle over here on the side, that is a golden rectangle.